Have a good day. In this video we will discuss Chapter 9. Analysis of data. Statistical analysis, or statistics, is concerned with the development and application of methods and techniques for organizing and analyzing data, so that the reliability of conclusions based on the data may be evaluated objectively in terms of probability. Generally speaking, statistical analysis may be used to accomplish four basic purposes. 1. Statistics may indicate the central point around which a mass of data revolves. 2. They may show how broad or diverse the spread can be for a mass of data. 3. Statistics may reveal how closely or distantly certain features within the mass of data are related, as well as whether a relationship even exists. 4. They may indicate the degree to which the facts might have occurred by mere chance, or whether there is a probability of their having been influenced by some factor other than pure chance. Steps involved in data analysis. The establishment of categories. In order to organize and analyze the data collected for a study, it is necessary to place them in categories. The identification or establishment of categories should take place before the data are gathered. The actual categorization of the data takes place during or after the collection process. In establishing categories, four basic rules or guidelines should be followed. 1. The set of categories or values. 2. Each set of categories should be exhaustive. 3. The categories within each set should be mutually exclusive. Last, but not least, the development of categories should be based on a sound knowledge of the subject matter and an anticipation of likely responses. Coding the data. Once the categories have been established and data assigned to them, it is necessary to convert the new data or responses to numerical codes, so that they can be tabulated or tallied. These codes are, in turn, assigned to specified locations in data files, particularly if computer data analysis is planned. Analyzing the data. Descriptive statistics. Once the data are ready to be analyzed, the researcher can choose to utilize descriptive statistics, inferential statistics, or both. Looking first at descriptive statistics, which have been the predominant type of data analysis employed by researchers in library and information science. There are at least 6 basic functions that they can perform. 1. At the most basic level, the statistical analysis can indicate how many persons, objects, scores, or whatever achieved each value, or fell into each category, for every variable that was measured. These calculations, known as frequency distributions, are usually reported in tables. 2. When it may be difficult to grasp the overall meaning of frequency distribution tables, pictorial representations can be used to portray a variety of characteristics of the cases or individuals with respect to the variable or variables measured. 3. Descriptive statistics are capable of characterizing what is typical in a group of cases. Such statistics, referred to as measures of central tendency, commonly include the mean, the median, and the mode. 4. Descriptive statistics can indicate how widely cases in a group vary. 5. Descriptive statistics can measure the relationship between or among the different variables in the data. These are generally referred to as correlational or associational statistics. Finally, the reader should compare the percentage differences in the table in order to determine the extent to which relationships, if any, between the variables exist. Comparisons are always made in the direction opposite to the one in which the percentages were calculated. Analyzing the data. Inferential statistics. Parametric statistics. Parametric statistics require the assumption of a normal population or distribution. Parametric tests are relatively powerful, are likely to detect a difference between groups if a difference really exists. In other words, the power of a test is directly related to its ability to eliminate false null hypotheses. Some examples of frequently used parametric tests include the following. 1. Z-test. This test, using standard scores, tests the difference between a group's results and the results that would be expected due to chance alone. 2. Student's t-test. A test that can be used in place of the z-test where there is still only one group but where, in contrast to the z-test, the standard deviation of the population is not known. 3. Difference of means. A commonly used statistical test which utilizes the t-statistic, and which determines if the statistical difference between the mean scores of two groups is significant. 4. Analysis of variance, a statistical test which represents an extension of the difference of means test. It utilizes the F-statistic, and it tests for differences among the means of more than two samples or groups. 5. Post hoc tests. These test the statistical significance of differences between group means that have an overall difference calculated after an ANOVA or a regression analysis (RA) has been done. A. Tukey's HSD honestly significant difference test. This test is used to examine the pattern of mean difference and can be used with more than two groups. B. Sheff test, a test of significance used for multiple comparisons of means in an ANOVA. It is good for comparing unequal cell sizes and tends to err on the side of underestimating significance. 6. Reliability coefficient, a statistic that indicates the reliability of a measurement, a test, scale, etc. They range from 0, completely unreliable when observed variance is attributed to random error, to 1.0, completely reliable. A. Cronbach's, a measure of internal reliability or consistency of the items in an instrument that have more than two answers, such as Likert scales. B. Heuter-Richardson, measures the internal consistency or reliability of tests in which items have only two possible answers, such as yes, no or true, false. 7. Pearson's product moment correlation coefficient R. This test generally is referred to as simply the correlation coefficient. It measures the degree of linear association between two variables or the extent to which changes in one value correspond with changes in another value. 8. Regression, a type of analysis that, as is the case for correlation, can be used for descriptive and inferential purposes. Nonparametric statistics. Nonparametric statistics are considered to be distribution-free. That is, they do not require the assumption of a normal population and, therefore, are often used with smaller samples. Nonparametric tests are usually, but not always, used with ordinal level data. 5 common examples are as follows. 1. Chi-square test. 2. Mann-Whitney U test. 3. Wilcoxon sign test. 4. Spearman rank order correlation, or Spearman's row. 5. Kruskal-Wallis test. Statistical analysis software. Another comprehensive computer system for data analysis is known as SAS. It tends to be used most frequently by researchers and IT staff in technical fields, but the system can in fact be used for virtually all kinds of data. SAS can be operated through a graphical interface, or via application programming interfaces or APIs. Analysis of non-quantified data. The analysis of qualitative data differs from the analysis of quantitative data, not only in the nature of the data but also in the nature of the process. For example, qualitative analysis is not perceived as a separate phase as in quantitative research. In fact, qualitative researchers have frequently suggested that research design, data collection and analysis are simultaneous and continuous processes. Both types of statistics permit interpreting quantitative data in such a way that the reliability of conclusions based on the data may be evaluated objectively by means of probability statements. The typical basic steps in statistical analysis are categorizing the data, coding the data, and calculating the appropriate statistics. That's all. Thank you, and God bless.